So it's going to be an integral from x equals 0 to x equals 4, and the integral is going to go y equals 0 to y equals 5. The function is basically that guy, and that guy is going to get turned, well, that guy's just basically is just going to be y, right?
Mm-hmm.
I don't need to do anything with him. And then I'm going to have the big square root guy, and a dx dy. And this fella is dg, the derivative with x, the derivative with y, and should be a 1, right?
Yeah.
Can I just not bother writing all these numbers and imagine that they're there all the way through just because I can, right?
Yeah.
Okay, you differentiate this guy here with respect to x. I've decided that it makes my life easier if I just distribute the 3 halves. So when you differentiate with respect to x, that guy gets you nothing. So you're multiplying by the power and reduce it by 1, which ends up being just x to the half. And then you square it. Are you cool with that?
Yep.
And I think by symmetry, I can write that down without thinking.
Yeah.
Okay. So we now have a y, a square root of x plus y plus 1. We've got a dy, we've got a dx. Were you pretty much the same place?
Mm-hmm. Yeah.
Right. So it's nice when things get awkward, right?
Yeah.
So I don't really want to try and integrate this with respect to y, because I just have a big issue with the fact that the order of integration is not helpful. So
yeah.
I'm going to switch it. I think I better put in the numbers just for this one at least. Because and so by doing that, I'm not changing this guy. Oops. I'm just deciding to do the x's before the y's. It's much easier to integrate this with x.
Yeah.
Right. So if I call it y, x plus y plus 1 to the half, then I can essentially just do a power rule, which is add 1 to the power and then divide by the new power. And since it's just x inside, technically times 1 over 1, but that doesn't do anything, so I don't care. Then I'll evaluate it at 0 and at 4. So that's going to get me 2/3 y. 4 plus 1 just gets me 5, so it's 5 plus y to 3 halves. Take away 2/3 y. 0 just gets me well, y plus 1 to 3 halves. Are you good at that point?
Yes.
So I'm now going to stick in the integral from 0 to 5 and tag on a dy. And I'm going to do this as 2 separate questions. So let's focus on this one.
Okay. And then could we pull out the 2/3 outside of the integral?
Oh yeah, let's do that.
Okay.
Should have thought about that, right? Yeah, we're going to end up with later on fractions, but at least they're out the road. So stick it out here. And let's focus on this one.
Okay.
This one here is going to be done almost exactly the same as that, with the minor difference of a y plus 1, right? So this question is a u-sub. And if you differentiate with respect to y, you get 1. And if you do the crossover, it's a very simple u-sub. Agreed, there's not that much going on. And so it's going to be 2/3 an integral. I'm going to leave that as y for a minute. And this now becomes 3 halves, and this now becomes du. And if you go up here, you can rearrange this and get y in terms of u. So I now have 2/3 u take away 5, u is the 3 halves du. which becomes u to the 5 halves, take away 5u to the 3 halves. Are we cool with that?
Yep.
And you got similar things?
Yep, I got the same thing.
It must be something really annoying, Mia. You know it's going to be a 2 that should be a 4 or something.
Yeah.
A plus it should be a minus. But we'll just keep going and see what happens.
Okay.
It's going to be 2/3, add 1 to the power, and then divide by the new power. Add 1 to the power, and then divide by the new power, which is 2/5. And 2/5 is that, oh, that doesn't play well. Okay, so 25 halves. Did you get that?
No.
We'll check if I'm right. It's 5, and the new power is 5 halves, and you divide by 2/5. Okay, I was wrong. Did you get 2?
Yes.
Okay. See, I would have made the numericals like that. And then you return back to the 5 plus y's. And evaluate them at y equals 0 and 5. Okay, so I get 2/3 of everything. So it's going to be 2/7, 10 to the power of 7 halves. Take away 10 to the power of 5 halves, minus 2/7, 5 to the power of 7 halves. Take away 5 to the power of 5 halves.
And then should there be a 2 in front of the second? Yeah.
There's a 2 there. Here.
Yeah.
Here.
Yeah.
Yeah, right. So, okay, let's see what the pieces give me. I have a 2/3 of everything, which I'll worry about later. 10 to the power of 7 halves is like 3.5. So what that gets me is 1,000. So I get 2,007 and a square root of 10. And this guy gets me 2.5 power. So that gets me 100 and a square root left over. So take away 200, also be a square root of 10. And you go with that one.
Yep.
And this one here, God, there's a lot of brackets going on here. I'm going to get 2/7 times 3.5 is 125 square root of 5. And that guy there is 2 times 25. So that's 50 square root of 5. Do you get things that look like that?
Yes.
Whoa, this thing is horrible. Okay, that and that can combine into some version of the square root of 10, and that's going to combine into some version of square root of 5. Well, let's find out. Hopefully the calculator can handle it. 2,007, take away 200, and then do a math, make me a fraction. Please work. Oh, thank goodness. Negative 1,207, and this guy is 2/7 times 125, take away 50, and turn that into fractions, and I get negative 100/7. Do you get that?
Yes.
Okay. Well, let's bring out a 7, and that makes that 21. And let's bring out 100, so that makes that. And so what am I left with is that guy, because I'm taking out 100 down to 7. That's gone. I'm taking 100, and I get negative 12 of them. So that package is what my first one got me. And you're still with us, right? You got the same results.
Yeah.
So it must have happened on the second half.
Yeah.
Okay. Let me see if I can jump to what they tell me the second half is. So they have this line and they have this line. So we're good up to here.
Mm-hmm.
All right. And what did they do after that? Ugh. Okay. That doesn't look right. I'm trying to see why my answer, why this bit isn't in their answer. I know there's two pieces, and that's fine. You can have two pieces all the time. See, they didn't. They just skipped like 4 lines and jumped right into like some line down here without telling me where the bits came from. Let me show you what we've got. Maybe you can see it. One of the reasons I don't like looking at their answers is that they skip so many things that it tends to confuse me rather than get me. Right, so can you see there's our, that's kind of where we were.
Yes.
This guy here is representing this side here, up to here at least. That's representing the guy we've just done.
Okay.
Right, there's the 7 halves. And they have a 6 there. They have a 6 there, not a 5. And why is that? Why is that
the
a
numbers
6?
are switched around, I think. Because in mine, the X goes from 0 to 4.
Oh, God, right. So we can't even use this answer.
Yeah.
Because the numbers, the intervals. Okay. Right, well, back to square one. You've done this and you've got the exact same as me so far, right?
Yeah.
And so all we need to do is go to the second piece of the puzzle and essentially go through the same process. And we should be able to, at the end of that, why have I not got my guy? Who have I missed? I broke it into 2 pieces. So where is the other piece? Where is the other piece? Oh, here it is. Okay. So we know this piece ends up being this guy here. And now we'd have to figure out what this piece is. Okay. I'll forget the fact that it's a negative and it's a 2/3, right? That way we can just focus on this guy.
Yeah.
And I'm going to do the same U-sub trick that we did before. Let's just do a quicker version of it. And so we're going to have y, u to the 3 halves, du, and that becomes u minus 1. Just like the last time. And that becomes 5 halves and 3 halves. And that becomes, oops, almost made a mistake there. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Are we good with that?
Yep.
Right. Now I'll convert it back into y plus 1. And your integral values for y were 0 and 5.
Yeah.
Okay. Probably should start this at the top of the next piece of paper. We're going to get, in the first one, take away the second one, we are going to get 2/7, 6 to the power is 7 halves. Take away 2/5, 6 to the power 5 halves. Minus, when you put in 0 here, you're going to get 2/7. Doesn't really matter because 1 to the power is still that one. Take away 2/5, so that one comes out a little bit nicer. This is 6 cubed and a square root of 6. So 6 cubed is 216. Double it up, you get 432 over 7. And this guy is 2, so that's basically 36. So you're going to get 72/5 square root of 6. And this guy here, I'll just leave alone for a minute. These two can be combined. 432/7. Take away 72/5, and then make it a fraction. And I get 1656/35 square root of 6. Does that look good?
Yes.
And this fella here is just going to be some fraction with 35ths on it. So it's going to be 2/7, take away 2/5. Make that a fraction. And all sorts of buttons I shouldn't be hitting. There we go. And we get take away -4/35. Which means we're going to add it. So I'm going to have 1656/35 square root of 6 plus 4/35. And there's a -2/5 going on here, which I'll now bring into the mix. And that's going to get me, what on earth is that going to get me? Well, actually, let's pull out the 35ths, because at least that's common. What do I get for that? I get 5 times 35. I get 175. Can I pull out a 4? Yes, I can. So that'll become 8. And if you pull out a 4, that's a 1. That's going to be a square root of 6. That's used up. What do you get if you take 1, 6,
the
5,
outside
6?
number is -2/3.
This here?
No, the one farthest to the
here?
left. Yeah, it's 2/3 instead of 2/5.
Is it? Isn't it 5 because the power is 5? It should be a 5.
I thought that was the one you're pointing at. I thought that was in the equation.
Okay.
That's part of the equation.
Oh, you mean, yeah,
like
no, I'm pretty sure that's a 5. Let me just check it. Right, add 1 to the power, divide by new power, add 1 to the power, that is a 5. So that should be a 5. That is a 5. And am I putting that in the right place?
Because you already did that one.
Am I looking at the wrong blinking one?
I think so.
You're right. It's this one. At least we did it here and not way up there. So
yeah.
I can still pull out 35, but now I'm going to get 105. And I can still pull out 4. And that means I'm still going to get a +1 there, but this is going to change a little bit. This guy is going to be 106.56 divided by 4, and I'm going to get 414 of those guys. So take away. Okay, so we have the original one looked like this. Take away -8 105s. That guy. Do we look good?
I didn't get that, but it looks good now.
Okay, now the question is it the right answer? Because I could have made the mistake. And with the number of things going on here, we're trying to juggle an awful lot of balls. It's quite easy to put a plus or a 2, like I put a 3 and I didn't put a 3 where I should have. So here goes Here goes nothing yet. Let's find out. Question 8. It's 8/105. Ooh, they have put everything together, and according to them, you can get, I'll show you. According to them, you can actually get a common factor out of all of those terms. At least I can see the 8/105, right?
Mm-hmm.
So if I pull that out, they're making this switch places, I guess, which is, that's a -1. That becomes -414√6. Both of those are there. That's a good sign. And then I have got the other two guys. Now that's 750√10. Right, so they have a 750√10, and they have 125√5. Okay. It could be right. It could just be a different version of the same answer.
Mm-hmm.
So I don't feel so bad. At least I know half of it is right, because it does match.